Before I start this video, I want to ask you to support me by subscribing to my channel. And please like this video if you find it helpful. And of course, if you have some questions or suggestions, welcome to the comments. And we jump right in.
Hi everyone! In today's video, we'll try out the scheduler package that was introduced in Symfony starting with version 6.3, and as always I start with some theory. The Symfony scheduler component is a powerful tool for managing scheduled tasks within your Symfony applications. It provides a flexible and expressive way to define and execute recurring jobs, making it easier to automate various maintenance, background processing, and data synchronization operations. Key features: declarative task definition. You define tasks using a fluent interface, making it easier to specify schedules such as daily, weekly, monthly, or custom intervals. Integration with Symfony Messenger. The scheduler leverages the Symfony Messenger component for dispatching and handling tasks, enabling you to utilize various transports, such as in-memory, AMQP, Redis for boost and scalable task processing. Advanced scheduling options. Supports complex scheduling scenarios including cron-like expressions for precise control over execution times, time zones, schedule tasks for specific task zones, conditional execution, define rules to conditionally execute tasks based on specific conditions. Extensibility. You can create custom schedules and handlers to tailor the scheduler to your specific needs. Debugging and monitoring. Provides tools for inspecting scheduled tasks, viewing execution history, and troubleshooting issues. Use cases. Maintenance tasks, database cleanup, cache clearing, log rotation, and so on. Background processing. Image processing, sending emails, generating reports, and so on. Data synchronization. Importing data from external sources, updating data periodically, and so on. Scheduled notifications. Sending reminders, alerts, or newsletters. Core concepts of the scheduler. First, message. A task is represented as a message, similar to messenger messages. These messages are executed by a handler. Second, handler. The handler is a service that processes the logic of the scheduled task when the message is dispatched. Scheduler transport. Unlike messenger, where messages are dispatched immediately or with a delay, the scheduler transport autonomously generates messages at defined frequencies. Heap initialization. When the worker command starts, it loops through all defined recurring messages, calculates the next runtime for each message based on its schedule, builds a sorted heap of messages with the soonest runtime at the top. After building a sorted heap of tasks based on their scheduled runtimes, the scheduler starts the working to process these tasks. Fifth, worker loop. The worker runs in an infinite loop. It checks the current time against the heap stop message. In this loop, the scheduler waits until the scheduled execution time of the next task. If the time matches or is later, it dispatches the message through the messenger component, asks the recurring message for its next runtime, updates the heap with the new runtime. The scheduler component offers two ways to consume messages depending on your needs. Using the messenger consume command. This is a recommended solution when using the scheduler component in the context of full-stack Symfony application, and also creating a worker programmatically. This approach is more suitable when using the scheduler component as a standalone library or in custom setups. 6. Message dispatch. The dispatched message is sent to its handler for execution. 7. Repeat forever. The heap is continually updated with new runtimes, and the loop ensures tasks execute as scheduled. Scheduling recurring messages. A recurring message is a message associated with a trigger, which defines how often the message is executed. Triggers are the core concept that controls the scheduling of recurrent tasks in Symfony. Each trigger determines the next execution time based on its specific logic. Symfony provides several types of triggers, making it highly flexible for different use cases. Types of triggers. Cron expression trigger. This trigger uses the familiar cron syntax, widely known for scheduling tasks in Unix-like systems. Callback trigger. This trigger allows you to use a custom PHP callback to determine the next run date. Perfect for tasks with dynamically calculated schedules. Exclude time trigger. Excludes specific time from a given trigger. For example, you can prevent tasks from running during maintenance windows or off-peak hours. Jitter trigger. Adds a random jitter, a slight delay or advance, to the triggering time. Useful for eventually disturbing the load of scheduled tasks, so they don't all execute at the exact same time. Periodical trigger. Uses a data interval to schedule tasks at regular intervals. Trigger decorators. Some triggers act as decorators, modifying the behavior of the trigger they wrap. These are exclude time trigger, exclude certain times, jitter trigger, adds randomness to the execution time. These decorators allow for even more granular control over task execution. Perhaps that's enough theory. Let's try the component in practice. So, first let's install scheduler component with next command. And if messenger component wasn't installed yet, also install it. If you need tutorial about messenger component, then go to this link. So scheduler is tightly integrated with messenger. It leverages the messenger in structure to enqueue scheduled tasks for subsequent processing. The first step in working with scheduler is to define the task to be executed. In Symfony, this task is called a message. A message is an object that contains all the necessary information to execute the task. So let's create it. So the message contains the property named message to store the message text, and created add to store the creation time. Next, create the handler that processes that kind of message. So, here in walk method will be called when log message is dispatched through messenger. So, the handler receives a log message object, creates a datetime immutable object for the current timestamp, calculates the time difference between the message creation time and the current timestamp, and logs the message, its creation timestamp, and also the calculated processing time. For logging, we are using the monolog bundle, but we won't be delving into its implementation in this specific video. Instead, we'll focus on the scheduler. And now we need to create a class in which we will define a dispatch schedule for messages. So let's do it. Let's talk a little about what's going on in this class. A schedule attribute. This attribute tells Symfony that this class is responsible for providing a schedule for tasks. It automatically registers the class as service in the Symfony container. And also here we should add name for this tag. The schedule name is important because it allows you to differentiate between multiple schedules defined in your application, and the name of the schedule is used to determine the name of the transport used by the scheduler component to store and execute the schedule. If no schedule name is provided, the default name is default. The default transport name for the default schedule is scheduler_default. This convention helps to clearly identify the transport associated with each schedule. The class implements the schedule provider interface, which is an interface defined by the Symfony scheduler component. This interface requires a class to have a getSchedule method. This method returns new schedule. This line creates a new instance of the schedule class, which is used to define a collection of scheduled tasks. This method is used to add individual scheduled tasks to the schedule instance. In this case, there is a single call to add method with 3 recurrent message instances as arguments. And recurrent message every. This creates a new instance of recurrent message, which represents a task that should be executed repeatedly according to a specific schedule. So this code defines a schedule that includes 3 tasks: log message every 10, 15 and 20 seconds. And actually you can create multiple classes that implement schedule provider interface. Each class can define a separate schedule with its own set of recurrent messages. And this approach is useful when you need to manage different sets of schedules independently. Or alternatively, you can create a single class that handles all the recurrent messages in your system. And this approach might be more suitable for smaller application or when you want to keep all scheduling logic in one place. When you create a schedule provider, a new messenger transport is set up. To process the recurrent messages, you need to run a working using the messenger consume command. In your terminal, run bin console messenger consume with the -v option to view the log messages from your handler. Then specify the name of the newly added transport, scheduler _ log _ task _ provider, where log _ task _ provider is the name defined in the schedule attribute. One crucial aspect of a reliable scheduler is maintaining its state. In the current implementation, restarting the scheduler would cause it to lose track of its progress. For example, if message is scheduled to run every 10 days and the scheduler restarts after 5 days, it would mistakenly wait another 10 days from the restart time, potentially missing the scheduled execution. To address this, we need to make the scheduler stateful, and this can be achieved by introducing a cache mechanism. So, in the log task schedule class, we injected the cache interface from Symfony cache component into the constructor. And in the get schedule method, call the stateful method on the schedule object and pass the injected cache instance. By implemented stateful scheduling, you ensure that your scheduled tasks are executed reliably and consistently, even if the scheduler is restarted or interrupted. Okay, we stopped the worker and restart it. The first time we do this, it's going to have the same behavior as before. Let's do it. But now let's stop this. And wait some time and watch what happens when I restart. It catches up, so the messages happened immediately. The state keeps track of the last time scheduler checked for messages, and so if your worker gets turned off for a bit, when it restarts, it reads the time and uses it as its starting time, so it can catch up with all the messages that it missed. It does mean that you may have some messages that are executed multiple times immediately, but it won't miss anything. Another way to create a recurring message is by adding one of these attributes to a service or a command, as periodic task or as cron task. So let's try to do the same but with attribute.
In Symfony, we can easily debug and inspect our task schedules using the Debug Scheduler command. This tool provides a comprehensive overview of all registered schedulers and their associated tasks, along with detailed configuration parameters. If you are leveraging attributes to define tasks, they will also be displayed, allowing you to ensure everything is set up correctly and functioning as expected. So let's try it. To view all tasks for a specific date, we need to run. To view tasks for a specific schedule on a specific date, we need to run. And to view all registered schedules and tasks, we need to run. And for today it's all. Thanks for watching.
I hope you enjoy this video and see you next time.